For our last problem in this section, we're going to once again take a look at a fourth order equation. And we always start off with our y of t equaling e to the rt. And if we take the first, second, third, and fourth derivatives and substitute them in, cancel out the exponentials, we get an r to the fourth plus 8r squared plus 16 is equal to 0. Once again, when you graph this polynomial equation, it will not cross the x-axis at all. All the solutions are complex. So therefore, we have to go through and solve for the r by factoring. So this factors as an r squared plus 4 twice. And with that r squared plus 4 twice, that's going to get us a bit of an interesting problem with our repeated solutions. So r squared is equal to negative 4. R is equal to plus or minus 2i. So that's the only values of r that we get. So we know we're going to have sines and cosines, but we have to also watch out for linear dependence. So our y of t will be formed as 4 terms. It's going to have a c1 cosine of 2t and a c2 sine of 2t. And now to break the linear dependence, we're going to have a c3t cosine of 2t and a c4t sine of 2t. And now this 4-term solution will have 4 functions that are linearly independent, and they will also be easy to check that they work by taking the first, second, third, and fourth derivatives, substituting in, and seeing that they work. So that is another example of a fourth order equation for us.